All right, thank you all for coming. Today I'll be presenting our paper, Extending Manual Drawing Practices with Artist-Centric Programming Tools. And this is work done in collaboration with Joel Brandt, who's here today, and also my co-authors Radomír Mech and Mitchel Resnick, who are not present, but present in spirit. Throughout human history, artists have used their hands to express themselves. And the emergence of computers has displaced some forms of handmade art and altered others. But computers have also provided alternative artistic opportunities. Computer programming has given rise to new art forms, like procedural art, in which artworks are described as a series of computational rules, models, relationships, or instructions, generally in the form of a computer program. Procedural art offers a host of different creative opportunities, and some of the primary opportunities include the ability to create artwork that is autonomous, dynamic and responsive, and generative, capable of producing works not explicitly conceived of by the original artist. Procedural and manual practices have fundamentally different qualities, but they are not mutually exclusive. The breadth of applications offered by procedural art suggests opportunities to extend traditional arts like painting and drawing. Yet the building blocks of procedural art, namely existing programming languages, and the mechanisms through which they're expressed, namely representational programming environments, are often at odds with key forms of manual expression and key practices in manual workflows. So recognition of the opportunities of combining procedural and manual art and the limitations of existing programming environments for manual practice led to our research question. How can we develop programming environments that support the integration of procedural and manual art? Our observations led us to develop an approachable and expressive environment for personal drawing tool creation that empowers manual artists to create procedural tools that support their established practices. So in the remainder of this talk, I'll go into greater detail about some need-finding research we conducted with actual artists to explore some of the opportunities in these spaces. And then I'll talk about dynamic brushes, which is the system we developed in response to this need-finding research. I'll describe our evaluation of dynamic brushes with professional artists and conclude with an analysis of the results of our study. To better understand the opportunities and tensions between manual and procedural practice, we conducted 9 interviews with professional artists. Within our subjects, 5 worked primarily with manual tools, and 4 used programming extensively in their work. Our interviews lasted between 30 minutes to 2 hours, and we built on prior research in computational learning and creativity support to analyze interview transcripts through 3 themes: learning, process, and expression. Today I'll focus on a few key points from these themes with representative quotes from artists in our interviews, but you can see our paper for an extended description of this process in general. So one common tension in many forms of end-user programming is the challenge involved in learning programming languages and tools themselves. But artists have specific approaches and motivations for learning things. So we examined the specific issues that manual artists encounter when learning existing procedural tools for art. Here, Nina, who's a printmaker and a graphic artist, spoke about her reluctance to learn existing creative coding frameworks and how that was connected with her view of the aesthetic limitations of these systems. She talked about how she was more interested in learning technical tools that weren't just a visual end into themselves, stating that she wanted to be able to create something personal with the tools she used. And Nina's comments here are echoed by our interviews with other manual artists, where they point to the great potential of programming and the possibilities it offers, but the feeling that artists had where the existing programming tools were hard to reconcile with their personal creative objectives and aesthetics. This connects to these broader learning challenges that often correlate with learning thresholds encountered by learners of general-purpose programming languages. But our interviews also suggested a disconnect between the primitives of common creative coding models and the aesthetic concerns of manual artists, where creative coding tools often focus on the manipulation of simple geometric forms, which can be highly expressive in some forms of work, but are often not well matched the aesthetics that emerge from practiced manual control. So building on this idea, our interviews also examined the forms of expression procedural and manual artists valued within their respective practices. And the connection between manual control and procedural expression came up repeatedly when we talked with manual artists. Michael, who's a studio artist and illustrator, described how his work was defined by the manual deviations in his lines, stating that when you look closely, his work was riddled with wobbles and whatever was going on in his head at the time. Interestingly, not just the manual artists, but also some of the procedural artists we spoke with expressed dissatisfaction with the aesthetic qualities of computationally produced forms. And so to understand how they address this tension, we talked with artists whose work contained line qualities similar to found in manual art, but was produced with procedural tools. And we discovered a common approach in these interviews, in that the artists often use their programming expertise to create custom software that let them integrate drawing by hand and creating procedural styles or effects. So this is a representative work created by the artist Eric Natsky, who we spoke with. And Eric creates custom software that enables him to draw freely with a digital stylus, while the software modifies the color and quality of his strokes by referencing different input data. So our need-finding research demonstrated overall how existing programming languages and interfaces, while highly expressive in some contexts, can be poorly aligned with the forms of expression that are important to manual artists. And they also revealed how experienced procedural artists circumvent these limitations by building their own tools. So these observations led to the idea that we could aid manual artists in integrating procedural and manual creation through a meta tool, or through a system for building tools. So the resulting system, Dynamic Brushes, is a visual programming and direct manipulation drawing environment that enables the creation of ad hoc drawing tools that transform stylus inputs to procedural patterns. Building Dynamic Brushes required us to develop two components: a programming model applicable to tool development, and an interface for writing programs and also for creating artwork. And we built these two components in parallel through an iterative approach, and we guided our iteration on a set of design objectives connected to our original need finding. So because we were targeting manual artists, we sought to create a programming platform that was approachable for new programmers, which meant we designed our programming model around a small number of primitives, and we also designed our interface in a way that sought to create approachable entry points to programming. We also sought to make our system relevant to the aesthetic concerns of manual artists, so our goal here was to emphasize compatibility with manual practice and balance support for both procedural and manual expression. So this translated to us working to structure our primitives in a way that was expressive and scalable for professional artists, but also to select primitives that were compatible with manual drawing input, and in our interface to develop a design that prioritized both programming and manual creation equally. So now I'll talk about how we actually implemented these things. Programming in Dynamic Brushes is structured around the creation of brushes, which are interactive drawing objects that respond to manual input from the artist. And each brush object has properties that define the geometric transformation of its strokes. For the sake of time, I'll touch briefly on the programming model. There's extensive details in our paper, and I'm happy to talk in more depth after the presentation. But we centered it around three core constructs: property mappings that are declarative mappings between some input data and brush property. And the primary form of input in the system is stylus data, but mappings can also use generators as an input type, which are data types that produce a sequence of values corresponding to a given function. So for example, modulation with a sine wave. Property mappings are structured inside of states, which describe collections of mappings that hold true when the state is active. And then finally, state change is enabled through event-driven transitions, which can occur on a variety of different triggers, including stylus events, geometric events, and intervals of time. And transitions can also include actions, which are discrete methods that are called once when the transition occurs. And I'll touch on those more in a moment. We chose this combination of mapping states and transitions because this set provided an expressive representation for integrating procedural and manual control, while also offering a way to offer approachable starting points for making interesting things with simple programs. And this model builds off prior work in integrating states and constraints. Our interface is divided between a pressure-sensitive pressure-sensitive tablet and stylus, and a programming environment on a laptop monitor. The artist uses the tablet to author artwork with the selected behaviors they've defined in the system, and we developed it to resemble many of the components of more traditional bitmap drawing software. And then the desktop interface contains a visual programming environment where the artist can drag out components and use them to author the actual brush behaviors. We chose to develop Dynamic Brushes as a visual language to support this easier entry point. And visual languages as a whole can take a lot of different forms, but in general, they offer this opportunity to produce syntax that's more discoverable and can encourage risk-free exploration in ways that some textual languages don't. So I'll quickly demonstrate the functionality of our system through some sample applications, and I'll touch on key functionality here. There's full documentation for all of these brushes in the paper itself. So simple programs can be composed that replicate the functionality of traditional bitmap brushes found in software like Photoshop by mapping stylus position to brush position, which is being done here. But it's possible to really quickly translate these simple traditional brushes into unconventional ones through the addition of generators. So the addition of generators in this brush to the scale property creates a brush that modulates its scale as the artist draws, producing this undulating pattern. And you can use a similar approach of mapping generators to different properties to produce a wide variety of different outcomes, with the basic idea that with a simple stylus path, you have variation of the actual line around the path itself. Similar to the automation that's enabled through conventional programming, in dynamic brushes, it's possible to create behaviors that operate independent of stylus movement. So transitions driven by time intervals enable the production of regular geometric shapes and patterns, and this is kind of one example of that approach. Documentation of how we do this is described in detail in our paper. But it also enables the ability to create brushes that combine automation and manual input. So here there's a timer-driven brush that's automatically drawing a wave pattern across the canvas, while the artist uses the stylus to manually modulate the heading of the brush and the diameter of the stroke. One of the most powerful aspects of programming in general is that it can be used to perform multiple actions simultaneously, and this can be used to produce intricate generative artwork. And dynamic brushes enables a similar effect by the ability for one brush to generate instances of other brushes. So this is facilitated through the spawn action, which is an action that enables one brush to generate a set number of instances of any other brush behavior, including its own. It's possible to combine spawning with timer-driven behaviors to produce brushes that integrate automated drawing effects with manual control, such as this drip brush. And to talk a little bit about how this functions, it's being created by a parent brush that follows a stylus and on a regular timer interval spawns a single child. The behavior for that child is shown here. That child then draws automatically downward on its own timer and transitions after a certain amount of time to a second state where it's mapping the diameter to a sine wave generator, which creates this drip-like effect at the end. Moving to our evaluation, in evaluating our actual system, it was important to examine how our implementation aligned with our original design goals. And so we sought to examine dynamic brushes' expressiveness, learnability, and compatibility with manual art production in the hands of actual professional artists. We used a 2-week study to evaluate our system with professional artists, and this approach built on prior methodology we used in a previous paper to evaluate a creative system with a small number of participants over an extended period. The 2 participants were Ben Tritt, who is a professional oil painter, and Fish McGill, who is a professional illustrator. And they both worked with digital tools, but were new to programming. We commissioned them to create several pieces of artwork during the 2-week period, and we collected data through conversations and meetings, written reflection, automated collection of in-progress artwork in the system, and evaluation of the resultant programs and artwork. I'll touch on, both artists created a lot of different things with the tool. We have further documentation in our paper. For the time being, I'm going to touch on some highlights of the study. So the illustrator, McGill, used spawning frequently towards the end of the study to create brushes that made multiple marks that were progressively offset from the stylus. And he later varied this behavior so that the offset marks were drawn with a variation in the line, so producing a smooth line pattern and then producing copies that had this ragged quality. And then he took this 1 degree farther by using a third-party tool to create an animated alphabet where he's animating between the different copies of drawings he's produced in dynamic brushes. The painter, Tritt, applied the system to portraiture, which was consistent with his prior work. And he took a different approach by developing brush behaviors that were designed to simulate the qualities of physical paint, but with some parametric control. So one of the things he focused on was developing a brush behavior that simulated flicking paint by extending the line for 1 second after he lifted the stylus from the canvas. So finally, to wrap up, I'm going to talk about some of the outcomes of our evaluation through the context of 3 analytic lenses: the ways in which dynamic brushes supported learning through practice, the opportunities more broadly of integrating art making and tool making, and the tensions and opportunities of aligning programming models with specific creative domains. Despite containing a small set of programming primitives, dynamic brushes scales to the creation of pretty complex programs and poses, therefore, potential learning challenges. But over the course of our study, we observed that while dynamic brushes took time to learn, both artists were able to use the system to the degree that they could author their own original brush behaviors by the end of the study. Both artists attributed their success and comfort in learning programming in dynamic brushes to the familiarity of the drawing interface, stating that it resembled tools that they were accustomed to using before the study. And they described how this provided a comfortable starting point to explore some of the more challenging aspects of programming. Furthermore, our study demonstrated how extended use of dynamic brushes helped to foster an understanding of some broader procedural concepts. So Tritt, who was completely new to programming before the study, initially struggled with the arbitrary structure of property mappings, saying that he didn't really understand why you'd want to use stylus force for multiple things. But then later he described how he gained an understanding of the power of actually using different mappings to control 2 or 3 things, and more broadly, the power of the arbitrary nature of creating mappings in the system in general. And he described how not only were these realizations important to him creating work, but how these insights made working with the system overall more compelling. Another aspect that the study revealed was this relationship between tool production and art making and some of the opportunities in that relationship. And by design, dynamic brushes encourages artists to blend these 2 spaces. But making tools and making art can involve different mindsets and can involve different approaches. So we were curious about how this combination would actually impact artists. And despite the tensions between these spaces, our evaluation demonstrated that while tool production is challenging, it's also a process that artists can enjoy and benefit from. So McGill, the illustrator, described how working with dynamic brushes not only let him make interesting things, but actually led him to question some of the norms of existing tools he was using, talking about how it made him less satisfied with the tool Photoshop. Tritt, the painter, went even further, saying how making brushes in dynamic brushes had implications not just for art making, but creative reflection. And he talked about how procedural tools in general enabled the resulting work to reflect the thinking process in a way that was not possible with analog mediums. So it just suggests some reflective opportunities of this approach. Finally, touching on the actual artwork itself, analysis of the resultant artwork demonstrates that provides a basis for comparing how our programming model was relevant to different aesthetics and different domains of manual art. And in general, McGill was more satisfied with the aesthetic results of his brushes than Tritt. And this suggests that dynamic brushes programming model was better aligned than with illustrative processes. And this in part has to do a bit with how McGill's line types focus on this composition and line quality, which aligned in many ways with the affordances of generators. By comparison, Tritt focused a lot on transparency and edges and kind of looked at a lower level degree of parametric control. But kind of the important takeaway of this is that we actually were able to use the study as an instrument to investigate how programming models could be relevant to a specific domain of practice. And this speaks to the broader potential of integrating systems development and extended evaluation to understand how to build domain-specific tools. So my time's up, so just to wrap up and summarize, motivated by conversations with artists, we created Dynamic Brushes, which is a visual programming and drawing environment for blending manual and procedural production. And our evaluation suggests that domain-specific programming instructions within a familiar interface can enable users to quickly and productively transition to developers of their own personal tools. So with that, I will conclude, and I would like to thank my fellow authors, Joel, Radomír, and Mitch, and also huge thanks to all of the artists who participated in our interviews and study. A special thanks to Jingyi Lee, who's also in the audience, who assisted heroically with our demonstration yesterday, and then also the Dynamic Medium Group and the Lifelong Kindergarten Group who supported this research. Thank you.
Hi, I'm Nadia from University of Washington. Thanks for your work. It's a really incredible platform that seems to have empowered lots of people to create new and exciting tools. And I guess I have a question that maybe coming from this community more, it seems like there's a big spike in the popularity of deep learning and art and AI and art and people talking about that. And since with this study you have had a lot of in-depth conversations with artists, I was wondering if it ever came up and what artists think about the possibility of Van Goghifying their art, if that is interesting to them at all.
Yeah, thanks for the question. So it's something that came up both in our need-finding interviews, because we spoke with artists who had experience in incorporating machine learning into their work, or artists who have been exposed to things like style transfer and are curious about the applications of it, and then also came up a bit in our discussions over the course of the study. And I would say there's kind of a lot of different points I can touch on here, but one of the interesting things from the need-finding research is how professional artists who are very experienced programmers react to those kinds of technologies, where they're interested in some of the potential that they offer, but also kind of really aware of the aesthetic limitations of that work, where it's kind of cool to be able to kind of create some kind of style transfer, but what they're seeking is the ability to express their own personal style, to explore new aesthetics and new ideas, and so the degree to which they're interested in some of those technologies is the degree to which they can do entirely new things with them. And sometimes, at least at this point, that often requires having a PhD in machine learning, for example, to actually be able to approach that. Moreover, something that's really interesting about artists, if you frame them as end-user programmers, which is one potential framing, is that they're both interested in the practical creative opportunities of programming, what you can make with it, but also how it lets you think about things in new ways. And this is something that came up a lot in our process. And so a lot of the foundation of my work is thinking about not just how can we use programming as a tool for helping people to make things they couldn't make otherwise, but how can we use it as a way for creative people to help think in new creative ways. And that's something that strongly connects to foundations in the work that's being done in lifelong kindergarten, for example. And so I sort of see opportunities for thinking about programming tools, whether it's the form of programming I'm offering or some new opportunities offered by technologies like machine learning, where we're thinking about not just what can people do, but how do these tools help people think in new ways and create new things.
Hi, I'm Jimmy Lin from Google. Thank you very much. It was very interesting. And I was just wondering, at the very end, you were talking about how the primitives that you offered seem to suit one style of art more than the other, line drawing versus transparency. Have you thought about what primitives you would introduce now to your system given to better support that type of work?
Yeah, so I think with regards to oil painting in particular, we focused a lot on, as I mentioned before, procedural control as a way to kind of spatially distort the actual strokes themselves. We weren't as focused on the idea of the strokes being comprised of actually like brush textures. And so there's another way we could redirect the system where it's sort of targeted at, instead of brush position or brush color, more like the actual texture of the brush itself, or the ability to play with the line edge of the brush. And I think an interesting experiment to do would be to take our existing state paradigm and change the actual brush properties we're working with, but have the same types of input, and see what different types of artwork might come out of that. But it would require sort of another slate of need-finding research to move into that. So that's something we're interested in terms of the types of brush properties that are actually relevant to what different types of people might want to be making. Thanks for your question.
Thank you.
I've found in systems similar to this that the artist will sometimes drag over random blocks, type expressions, and come up with a cool effect. But if they have an effect in mind from the start, they don't know how to do the programming to get from zero to there. Did you run into any issues like that?
Yeah, that's a really important question, and I think it's something that both touches on sort of like supporting people in informing their decisions in programming in general, but also in the case of our focus of manual art, how our programming model actually corresponded with how manual artists think about the types of things they're making. And one of the challenges with our need-finding research is because we were interviewing a lot of artists who had never programmed before, they had a very deep understanding of their practice, but that understanding was something that often was difficult for them to verbalize because it was understood through movement, through tacit control, as opposed to the way in which programmers might often have an unambiguous description of their process, because programming kind of requires you to do that. And so it was very hard for us from that need-finding research to sort of say, here's a programming model that might correspond with how artists think explicitly about how they work manually. So we tried to adapt for that by creating an exploratory interface where the consequences of exploration were low, at least enabling people to try things out without having catastrophic failures in their system. I think there's a lot of work to be done, and we've actually started doing some of this work in tightening the loop between creating a change in your program and actually seeing the results of that change. So borrowing on some techniques from live programming and programming visualization and inspection and applying it to our system. But more generally, I think this is another one of the interesting things of actually using the evaluation of tools like this itself as a way to inspect art practice, because as the artists in our system started to program, they also started to speak more concretely and unambiguously about the types of things they were trying to do, and that led to us having a better understanding of ways in which we might support those with the